All right, good morning and welcome, Journey team. We're going to continue our conversation about transverse waves today. I did already record this video once, but it was too long because I was spending so much time drawing and putting the information into the PearDeck slides for your notes today that I wanted to just re-record over the notes that I already took and save you some time. But what you can expect for today for your notes is spending about 15 to 20 minutes on science class today and then moving on. That doesn't include, though, your flashcards. Make sure that you do your 2 flashcards, which I'm going to give you your words for. I'll put it on the Google Classroom, but that is going to be for wavelength and amplitude. Make sure that you make those flashcards because those are key ideas for today. There also is a video, which is a really cool at-home project that I know some of you are looking for things to do at home, making your own homemade wave machine, and it involves duct tape, skewer sticks, and gummy bears, which the guy in the video calls them jelly babies, which is pretty funny. So go ahead and take a look at that too. There's also another YouTube video for anyone who feels that they want extra support. You want to hear the words and the descriptions of all the different wave properties. You want to hear it and see it in another version. That's always a great way to continue to memorize and learn and deepen your understanding for waves. So let's get started. Here's your I can statement. I can describe properties of waves, including speed, wavelength, frequency, and amplitude. Now, I had mentioned yesterday that in the PearDeck, or no, it was Edpuzzle, that we have to understand what the different kinds of waves are before we can start measuring them. And we are there. We're officially into knowing what wavelength and amplitude is. I will continue with speed and frequency as this unit goes on, but today it's wavelength and amplitude. This is reviewing the notes so that you have these permanently in your PearDeck notes, that there's 2 different types of waves, mechanical, and electromagnetic waves. Mechanical waves don't exist. They cannot travel unless they have a medium, unless they have a material that they can use for that energy to go from point A to point B. But electromagnetic waves do not require a medium. They can travel through outer space. They certainly do travel through a medium, and that's how we use it often here on Earth. And so it's very helpful that way. But mechanical waves would not exist if they don't have a medium in order to travel. Now let's get into this. Mechanical waves. I'm just going to tell you verbally what the words are that go into these lines and have you fill them in. Any wave which requires a medium, there's that solid, liquid, and gas, to travel from one point to another is called a mechanical wave. It means it has to have them. The second bullet, energy, will not be able to travel if there isn't a medium to move through. So the energy cannot move from point A to point B if it doesn't have that solid, liquid, or gas to get there. Please fill in those words. 2 kinds of mechanical waves. We have transverse waves or longitudinal waves. There are no excuses for not knowing how to spell these waves because the word is right below the line in there. For transverse waves, you see the up and down bobbing on the left-hand side. I'll circle this right now with my mouse. But then we also have, let's focus mouse. My cursor would not move. Let's do this. All right, getting fancy here. All right, so this is a transverse wave. We see this up and down movement. Longitudinal waves, you see these bunches of slinky bands that group together, and you can see them moving left and right. That makes a longitudinal wave. Please ignore the up and down line in the background. That is a transverse wave that they've somehow snuck into that picture. All right, so I can turn off this little fun flashlight and move on to the next slide. Become a transverse wave master by watching this video. Listen for words we've talked about so far. Words that you are going to hear are transverse wave, crest, trough, wavelength. We're going to hear amplitude, and look for new terms that will come that are from that I can statement. Look for those as you watch this video. Please watch it from beginning to end. It has some pretty good supporting facts that go with waves. Transverse waves, here's the definition or supporting facts about it. The definition of transverse waves kind of grabs all of this and puts this together. Matter moves perpendicular to the energy of the wave. That means that matter is moving up and down, whereas the energy would be moving left and right. And that difference would be creating, if we see this versus if we see this, that difference would be creating that right angle. So the matter is bobbing up and down, the energy is going left to right. So you don't have to write on this one. Oh, you do. You don't have to write into this picture. So we have the word perpendicular here. We have identifying blank and blank allow us to measure amplitude and wavelength. We need to be able to identify a crest, and we need to be able to identify troughs in order to measure how much energy these waves have. Examples of transverse waves. The first one is your rope, a wave traveling through a rope. A water wave is a combination, but it is a transverse wave. A guitar string that is being strummed is a transverse wave because it bobs up and down as energy moves up and back and forth through it. And so those are some good examples. Now, like I said, I did this ahead of time to save time. Shade each crest in blue. I only did one. Please do both of them. And each trough in green in order to indicate where they are located. This is just really putting this visual into your head that the crests are above the resting line and troughs are below the resting line. Now, in my first video, I went a little crazy on explaining this, but let me go ahead and re-explain this and tell you why there are so many lines going back and forth on this page. First of all, let's talk about the word wavelength. One wavelength, and if you listen to that, it's the length of one wave. That is the distance of one full crest and one full trough. You see why we need to know where crest and trough is at this point? Because we have to measure how long or how wide one wavelength is. Shade a full crest and a full trough to show how long each wavelength would be. What I did in the first video was I pointed out that there are several places where you can mark a crest and move on down the wave to mark the next crest and show one wavelength. Now, the very first obvious one is this one in purple. I'm going to get my little flashlight here. Okay, this one in purple. I started at the beginning of this crest, and I'm traveling as the crow flies, because if we measure how high and how low it is, that would really throw off our wavelength, because you could have an enormous amplitude way up high and go really far down for amplitude as well, and have an extreme number measured, but yet the distance from here to here never changes. So this is as the crow flies, as they say. Instead of following the road, you're going straight across from point A to point B. Now, between the beginning and the end of this purple line, there is one full crest and one full trough, and that is the very straightforward answer for measuring wavelength. But I used the yellow, the green, and the pink in order to show you something else. You see, if I measure from the top of this crest to the top of the next crest, between these two lines, I have half of a crest, a full trough, and another half of a crest. Together, that actually still follows my rules for measuring one wavelength. So I could measure at the top of two crests that are next to each other and know that that is one wavelength. Same thing down with the pink one. I could measure at the bottom, halfway, midpoint through this trough, and midpoint through the next trough. And I know that between these 2 points, I have a half trough, a full crest, and a half trough, and that equals one wavelength because I have that full trough, whether it's at the beginning or the end of this space. Last one, challenged a little bit more. The placement on this trough is about maybe, I don't know, a little bit less than a quarter of the way into the trough. But at the exact same place on the next trough, if I mark that location, I still have one wavelength because the full side of this trough with the partial end of this trough, I still have one trough and one crest between it, and that would be one wavelength. Hopefully you're catching on to that now. Over here, this little stick drawing of what kind of looks like a T-Rex dinosaur, that is our symbol for wavelength. And I want to challenge you, and just a little nod or wink to me that you are listening and paying attention in this video. I want you to draw the symbol for wavelength just like this. The symbol for pi is, two parallel lines with a little curve over the top. This is the symbol for measuring wavelength. All right, moving on. Okay, transverse waves. How many wavelengths occur in this 0.05 seconds? Now, if we're measuring wavelengths, we have to measure each crest trough pair. So what I have here is 1 crest trough, 2 crest trough, 3, 4, and 5 are in this picture. We're at the bottom for time. It says time is measured in seconds. It goes to 0.05. It doesn't even make it to a full second, but it says that this is occurring. Now, this would be very similar to some high intensity waves that are happening, not water waves, waves of a different kind. So when we look at this, I put the answer as 5, and there's my little sign for wavelength. 5 wavelengths are occurring in this 0.05 seconds. Next, another of our words of the day is amplitude. What is the wave, or what is the amplitude of this wave? Circle the answer on the left where the units are being measured. Amplitude is measuring how far away from the resting line this material gets pulled up or this material moves downward. Now, the term that's used for this is displacement. We've heard that word before, which means to push something out of the way. We do that in graduated cylinders all the time. When matter has been displaced, it would either go up or down, but it cannot happen at the exact same time. So we would never add this amplitude with this amplitude, because if we're measuring time occurring, they happen at different moments. So the amplitude for this crest, we're going to circle that unit right here. That is 4. And the amplitude for the trough, no coincidence, it is the exact same number. It is 4, because for every action, there's equal and opposite reaction force. Also, energy cannot be created or destroyed. So we see that similar crest trough symmetry that's going on there. So it's 4 and 4. You might be wondering why I wrote RL. That stood for resting line. This is where matter is resting when there is no energy traveling through it. Okay, today's flashcards. To make it home, wavelength, amplitude. These are found on the Quizlet link on the Google Classroom. Please use those and create your flashcards. You can keep on practicing on Quizlet, but there's something being said for writing it down, having it in your hands, giving it to a sibling or your parents and say, quiz me, I want to know these cards, and just learn them 2 words a day and keep on building on that rather than handing you 20 words. I don't want to give you that many words. So a little bit at a time. All right, let's turn my little flashlight off. For the next one, okay, I can't show it to you on this side of the slide, but this is what I was talking about with the science teacher who makes a homemade wave machine. I love it. Do it if you're feeling motivated to do that. I'd love to see it on a Flipgrid. We are doing Flipgrid on Thursday, so be ready for that. It will be a choice Flipgrid for you to try out. Maybe it won't be a choice. I don't know. I got to think about that. So keep your eyes open for Thursday for Flipgrid. Tomorrow will be something like a different lab. Last week you had to get the rope and shake the rope. So we'll figure it out. It's either a lab or a video. All right. We'll talk to you later. Have a good day. Miss you guys. Bye-bye.